So in today's workshop, we shall progress with the following agenda. We will start with a brief company introduction, followed by introduction to STAAD.Pro Connect Edition. Then we shall learn different ways to generate the model. Additionally, we will learn floor load calculations. We will be creating load cases like dead and live load. In today's session, I won't be covering the wind load case. Uh, if you want me to cover the wind load, I'll definitely create a separate video for that. So please give me your suggestions, or you can write me on my mail ID. I'll give you my mail ID in the last, in the end of the session. And then we'll be covering we'll be creating load cases like that and live load, and then we'll be assigning the floor load that we have calculated either by the ranges method or by grouping method. And after that, it will be followed by the question and answer sessions. So I request you all participants to kindly write the questions in a question and answer box. Also, we shall be providing with certificates to all on successful completion of all 4 workshops. As when you had registered for this workshop, you might have noticed there are it's a series of 4 workshops. So whoever attends the all 4 workshops will be awarded with a certificate. So I would request all the attendants to write your questions in the chat box so that I can answer them in the end. So we are Capricorn Technologies. We have a legacy of more than 3 decades. Capricorn has played a significant role in the country's computer-aided design adoption, and today we are concentrating on information modeling to address the start to finish design and construction difficulties faced by the building and infrastructure industries. Our team of more than 250 plus designers based in all major cities have constantly provided outstanding value, adoption, support, and services to optimize the true potential of more than 20,000 plus customers wholeheartedly, ranging from national importance projects to complex buildings. So now Capricorn Technology is now a Win0 company. On April 6th, 2022, we become a global company with our footprints and the impact globally. The foundation of Win0, the largest Autodesk Platinum partners, was the merger of historic brands, US CAD from US, CADline from UK, Capricorn from India, and A2K Technologies from Australia. Win0 is dedicated to educating its user about how the technology they employ now can assist them in moving toward net zero in the future and creating a better, sustainable society and greener future. So Win0 is known for its inclusive culture of putting people first and passionately resolving customer difficulties. So I'll just go with a brief introduction about STAAD.Pro Connect Edition. I won't go deeper into this because I've already covered this in my first workshop. So I'll just request you all again to go on our YouTube channel name as Capricorn Technologies. There you will find my workshop 1 series, and please go through that. But for today, I'll just cover the brief part of STAAD.Pro Connect Edition. So as we all are aware, STAAD.Pro is structural analysis and design program, and the user interface is simple and easy to learn. Although Connect Edition is consists of new user interface, and it is the most popular structural engineering software product for 3D model generation, analysis, and multi-material design. It is a comprehensive and integrated finite element analysis and design application that includes visualization capabilities, a simple user interface, and a wide range of design codes. By design codes, I mean you don't have to purchase international design codes. All the design codes are now inbuilt in STAAD.Pro Connect Edition under one single license. So STAAD.Pro provides structural analysis and design solutions for any project, including buildings, tunnels, plants, stadiums, transmission towers, and etc. So what are the new features in STAAD.Pro Connect Edition? First is new ribbon graphical user interface. So in this edition, tools are organized in much more precisely as they should be. Now all the tools are grouped under specific ribbon. Second is enhanced modeling. In enhanced modeling, you'll find a powerful modeling method that has been introduced, that is physical modeler. And not only this, also you will find the building planner option available when you just open the STAAD.Pro window. And thirdly is the fast solver. One of the major enhancement of Connect Edition is its inclusion of 64-bit solver, which can use the full capacity of the processor. So because of this enhancement, your analysis time will be reduced. And I have also proved this in my last workshop by comparing the results of VATI versions and Connect Edition versions. So please just, I'm requesting you again and again, do watch my first workshop series. It is very beneficial. And fourth point is code updates. Like I have told you, all the design codes are provided with STAAD.Pro license now. No need to purchase a separate license to use a different design code. This means you can use any international design code without any additional charge. And lastly, design module. All the design codes are provided with STAAD.Pro license. And in the design module, you will also find RCDC with all the access available. You may not need to buy RCDC license separately. You'll have the RCDC in a single license, STAAD.Pro or STAAD.Pro Advance, and you'll also have the access to STAAD.Pro Foundation Advance, in which you can design your foundations. So this was a quick introduction about STAAD.Pro Connect Edition and what all new has been introduced. So moving on to today's workshop topic, that is methodology and assignment of loads and model generation techniques. In this, what I'll do is my approach for today's session is, these are the load calculation that I have assumed, and I'll be applying the same loadings in the project or in the model live. So these are the calculation that I'll be considering for the dead load. For the floor load, basically I have considered is I have considered assuming the thickness of the slab as 150 mm, and self weight of the slab I've calculated. 25 is the density of the concrete. I have considered the floor finishing as 50 mm, or it could be anything as per the architecture or as per your plan. So, and ceiling plaster I've considered in the floor loads. So approximately it is 5.2 kilonewton per meter square I'll be taking as a floor load. And I'll be applying this floor load using two methods. One is by range method and second is by grouping method. And I'll be showing you what are the benefits of using both two methods, and in whichever method you are comfortable, you can use these methods in your creating your project or model. And these are the loadings for the internal walls, like as you can see in this diagram. But this diagram has nothing to do with my model. I am just place this diagram as an example. Like suppose these are the, in the toilet area, these are the internal walls. So how you will calculate the internal walls loading? So for that I have considered this. Everything is same, just I have added the internal wall loading. Like how you'll calculate the internal wall loading. Suppose it is of 115 mm thickness, and 22 is the density of the brick, and 3 is I've taken it as floor to floor height, and 0.15 is the thickness of the slab. So, and this I have calculated, and it has come out to be as 2.4 kilonewton per meter square. And this whole formula is also given in code book as well. So I have not just assumed it, I have calculated it. And in the internal wall area, I'll be using 7.2 kilonewton per meter square. And in the areas where there is no internal walls like bedrooms, or I'll just assume it, and I'll be applying 5.2 kilonewton per meter square over there. And these are the load for the wall loads. Like I have considered floor to floor height in my model as 3 meter, and wall thickness, external wall thickness as 230 thick mm. And these are the loadings that I have calculated. 0.40 is the depth of the beam. I have just deducted floor to floor height 3 meters and minus depth of the beam. 22 is the density of the brick, and 230 thick is the thickness of the wall. and this is 13.2 kilonewton per meter square, and in the above floors it's 3.5 meters. So in the area, on the area that is 3.5 meter of height, I'll be applying this load, and for the terrace, for the parapet wall, I'll be applying 5.1 kilonewton per meter square. So I'll just switch to my STAAD.Pro. So just give me a moment. I hope my screen is visible. Thank you for the confirmation. So I'll be creating a new project. For that, I'll just simply click on this new option over here. I'll select analytical. I'll say I'll give the name to my structure as building. I'll choose this only. I'll choose the unit as metric. I'll simply click on create option. So this is my STAAD.Pro Connect Edition windows in the starting window. So first we will see all the method generation techniques, how we can generate the methods, how we can use all the three methods like snap, not beam method. Your next is transitional repeat, structure wizard. So I'll be creating a model using all three methods in a single structure. So at the start of your structure, you'll see the blank window over here, which is this. So either what I can do is I can create the node from here by just giving a region as 000. So this is my 000 node. Or what I can do is, I'll click on this geometry option in grids. I'll select this beam grid. This is snap, not beam. So if I want to work in XY plane, so I'll select this plane. If I want to work in XZ plane, so I'll select this plane. And if I want to work in YZ plane, I'll select this plane. So as of now, I want to work in X and Y plane. So I'm just using this to uh, generate a model by using all three methods. So first is my this 0. Suppose I'll say 3 meters, because in the load calculation I showed you, I'll be using 3 to 3 meter height, but this is not the structure where I'll be applying the loads. Here I'll just create a model by using three methods. And suppose I'll go 3 meters here, 3 meters here, and again 3 meters here, and then down. Again, I'll click on this beam grid. So this is how I can use this. And if I want to create this 3 meter down, again, I'll click on beam grid. Either I can use this method. So this is my, suppose this is my first base is ready. And to see, this is my 000 beam. Sorry, 000 not point, origin point is this. And I want to create a like in Z direction, I want to create a model. So I'll just simply select whole structure. In geometry, you will find this option transitional repeat. I'll click on this. Suppose I'll be creating in Z direction. I'll be repeating it 4 times. Number of steps mean how many bays you want. And default step spacing, I'll take it as 5 meter. I'll click on link steps, geometry, and open base. Okay. So This is how you can create your base, or you can say plinth beams, or you can say a base for your structure. It could be anything. I'm just taking it as an example. It could be your solar panel. It could be your transmission tower. It could be anything. So this is how you can approach your structure. Either you can create a 0 0 0 node, and then you can use the transitional repeat option, or you can use snap node beam method. And if you want to, like, you know create stories first, let's say you want to create stories, how you can create, either you can do is you can select this whole structure again, click on transitional repeat in y direction, keep the default spacing as 3 meter, link steps. Okay, yes, see, one more story is created. And if you have applied the properties in the lower story, so automatically all those properties will be um assigned to the above floor as well. Either you can do this, or what you can do is, I'll just change the view. I'll select this view. Oh, sorry, I'll select this um, top story. I'll click on isometric view. I'll just right click from my mouse. I'll say copy, paste beams. Now I'll use the reference point as an option. Reference point. So this is the point, which means if I'll select this point as a reference point and I'll click on OK. Now I'll click this. This means that reference point will be copied from this node. I'll click on OK. See, again, if I'll click on this node, it will be created above. So this is how you can create your multi-story. Or what you can do is, suppose you can use the structure wizard as well in the same structure. Suppose I'll just just um, dimensioning what are the dimensions of the structure. It's 9 meter and 20 meter. Why I'm doing this? Because suppose you want to create a truss over the top story. So I'll just click on the structure wizard from geometry option. Suppose I want to create this half bridge. I am just taking it as an example. So length I'll take as 9 meters and width I'll take as 20 meters. And if you get confused in this, nothing to worry. It will give us a preview also before we'll assign to our structure. Suppose I'll just say 2, and number of bays along with is also 2. See. So this is correct. I'll just close this. Yes. It's saying I'll select reference point. This is my reference node. Okay. And I'll just click this node. Okay. Okay. See, if I just show you its rendered view, this is how it looks like. So this is how you can create your model very quickly by using structure wizard. And if I show you one more thing, if you don't want to like do this, if you are creating a multi-story building, or you're creating a stress structure, what you can do is, what I'll do is I'll just hide the structure by clicking on utilities in command files. I'll simply write here finish, because I'll do one more approach to create a structure, just to clear you one more time. Okay, so what I'll do is I'll click on geometry. I'll click on structure wizard. Here from the model type, you can select all the prototypes that you want to create. Suppose I want to create the frame models. And these are the bay frames available. Suppose I'll use this default value only. Whenever you will click OK, first it will show you the preview of this structure, like what are you creating. Suppose I want to create truss model. Suppose this only, I'll use the same values. I'll click on apply. This is how it looks like. So you can use this structure models in your structure and make your workflow easy. Suppose I'll click on waveframe. I'll use these values. I'll click on close. Yes. As of now, I have not created any nodes, so I can simply use these nodes. 0 means this is the origin of the node. As of now, my window screen is blank, so no need to worry. I'll click on OK. And to check what is my 000 origin, where is my, so this is the 000 origin. So this is how you can create your bay frames, trusses, your water tanks. If you want to create your cylindrical shape water tank, this is how you can use structure wizard as an option. Suppose I want to create this truss again. So I'll click on the structure wizard. Suppose now I want to create half roof. Wait, first I'll just see what are the dimensions. So I'll just simply click here. So like if you are like thinking ki how these tools are easily available or accessible to me. So what I have done is I've also explained in last workshop. This is the quick access toolbar. Just click on this drop down option, click on this more commands, and you can add these in your STAAD.Pro Connect edition as well. Suppose I want to add, I have already added some tools that I need in daily basis. So just for an example, I want to add structure wizard. Suppose I'll click on this, right option. Okay. See, my structure wizard is added in quick access toolbar and it is easily accessible to me. I'll click on this now. So wait, I'll just see the dimensions. This is 10 meter and this is 12 meter. In structure wizard, I'll go to let's create lattice truss, and it was 10 meters, 12 meters, and I'll take the height as 5 meters. I'll say 2 and 2. Apply. This is how it will look like. Or I'll say 4. Just I'm showing you how you're gonna place it. I'll click on OK. I'll select this node. Okay. See, this is how it looks like. 3D model. You can easily like change its height, its number of bays, in how many divisions you want to create the truss. So easily you can do this. And this is how you can use all the three like methods, either snap knot beam method or transitional repeat or copy paste method, anything that you want to create your model with, you can use all three methods. And now moving on to the loading part, I'll switch to the different structure in which we'll be applying the model. Oh, sorry, in which we'll be applying the loading. So just give me a moment. Yeah. So I hope my screen is visible with the new model. So I have already created this model with the help of all the three methods that I have just explained. And my floor to floor height of this model is 3 meters. This is 3 meters and this is 3.5 meters. So till plinth, first, second, and third floor, it's 3 meters, and third to terrace is 3.5 meters. And in this, I have already applied the properties. 350 by 500 is the column size and 200 by 400 I have taken the beam size just as an example. And I hope I'll not go in this detail how I have created the properties and how I've assigned it. And if you want any kind of help in this, you can write me or mail me. I'm always available on my mail ID and my number. I'll be sharing the both at the end of the session. So moving on to the loading part, how you will create the load and how you will assign the loading using the two methods. Here you'll find the loading toolbar. You will also find the loading ribbon tab above, but for applying the loading, for assigning the loading, just click on this loading tab. I'll not be covering the definition part today because in my next series, I'll be showing you how to assign the earthquake loading, and we'll be analyzing a structure using static analysis, which in which I'll be covering joint weight method. And in the second, I'll be covering response spectrum method. So I hope I'll see you all in the next session as well. So in today's session, I'll be just covering the loading, dead load and live load part. And in the next session, I'll be covering the definition part. So here you'll find the load case detail. To create the load case, just click on this load case detail, click on this option add. From here, just select the loading type as that, and I'll be giving the number as 3. I'll save my 1 2 number for the earthquake loading. So and in the title, I'll say member load. I am creating the separate load case for the whole load, which will be named as member load, because I think using this, it will ease my work. That's why I create a separate load case for assigning the whole loads. I'll click on add. So my member load is created. I'll again create a load case, which is for the floor load. Suppose I'll write the title as floor load. Here I'll give the number as 4. And now I'll create the live load. You can create the all 3 load cases in like एक साथ. Just write the title as live load. And so my all 3 load cases have been created. Loads. Now we will create the loads. So first let's assign the member loads. So click on this load case, click on add. From here, you'll find the different loads. But in today's session, I'll be just using member loads and floor loads. You'll find the multiple loads option, just explore it. And if you find any problem in assigning any load, just contact me. Just click on this member load. We'll be assigning the uniform force. Here you'll find the uniform moment load. You'll find the concentrated force, concentrated moments, like all the loads that is useful and that are considered in our model. Everything will be found in STAAD.Pro Connect Edition. There is not even a single load that wouldn't be found. So click on this member load in uniform force. Like I told you, I'll be using, if I show you for the member loads, yeah. So for member loads, plinth to second floor, where the floor to floor height is 3 meters, I'll be assigning 13.2 kilonewton of load. So let's create in W1 minus 13.2, because in STAAD.Pro y direction is upwards and we need to apply the load from upward downwards. That's why minus 13.2 in global GY direction. Click on add. And our second load was of 15.7 meter. Again, I'll create 15.7 meters. Close. So this red question mark explains that there is no, this load has not been assigned to any member yet. After assigning this load case, this red question mark will turn into green. So click on this load case first. Okay, I'll assign this 13.2 load on the members. First, I'll select the view and click on left view. So in all of these flows, load case is same, member load is same for all these 3 flows. I'll select it objects. I'll click the top view, but first wait. I'll only select the beams, horizontal members basically. So I'll go to geometry. Sorry, I'll go to select. In beams, I'll select parallel to Y and I'll inverse my selection. Now I'll go to view, selected objects. Now I'll select the top view. I'll click on this load. I'll just select the peripheral beams, because I'm applying the load of 230 thickness wall isometric view just to be confirmed. Now I'll just click here, assign to selected beams, assign. See, my member load has been assigned. Now I'll be assigning this 15.7 kilonewton of load on the top floor. Sorry, this uh, floor will be consist of this load. So I'll just select this floor. Instead of this load, I'll be assigning this load. And how you will toggle that load, let's see. But first I'll just assign this load. I'll first select the load, then select the members. Just to be sure, just click on the isometric view, assign to selected beams, assign. So in this floor, both the loads have been assigned. You have to, like, now you want to delete this load from this members. How you're gonna do it? Either you will delete this, but then the lower the load, this load that has been assigned in the lower floors will be deleted as well. What you can do is select this load. Here you will find the option of toggle load. Just click on this. Select the members from where you want to toggle this load. This. Just to be sure, go to isometric view. Now just click on assign to selected beams, assign. So your this load has been removed from this floor. Okay. Now on the top floor, like on the terrace or the parapet, wall load have to be assigned. I'll just select this top floor, selected objects, isometric view. Yeah. Select the top view. I'll add one more time. Member loads, uniform force minus 5.1 kilonewton per meter. Load. Select the load, select the members where you want to add the parapet wall. So all this information is given in the architectural plan, like where is the parapet wall, how much height, what are the floor to floor height. So I've just assumed it. Everything will be available to you. Click on assign to selected beams. Yes. So my member loads have been assigned. Just give me a moment. Yeah, sorry for the. Okay, so my all the member loads have been assigned. So this was a one way to assign the member loads. Now we'll be using another method of assigning the member loads. First, I'll just delete these member loads. I'll again create it, not an issue at all. Or what I'll do is I'll just toggle these loads. First, I'll select these floors, selected objects, top view. I'll select the members from where I want to toggle this load. Oh, my columns have also been, now my columns have assigned the load. Like, see, if you have used the toggle load option, what you have to do is you have to be very particular about the selection, because if you will select all the things, then the load will be assigned to the members which were not assigned first. So I'll select my columns. I'll click on view selected objects. I'll go to view, left view, right view, I'll select all the columns, assign to selected columns. Wait. Now I will remove this load as well and this load as well. I'll create one more time. Member loads. First we'll create minus 13.2, then minus 15.7 and 5.2. Close. So now what we can do is I'll be using the grouping method. I'll group these members in a single group and then I'll assign this load. And how it will be like easy. So to create a group, what you can do is you can simply press Ctrl plus G from your keyboard, and here select the selection type as beam. Write the group name as suppose if you are creating a group of plinth beams, then you can write the P1. If you're creating for F1, you can write the F1. But as of now, for example, I'll just say B1. I'll click on OK. And now what we have to do is we have to assign the members under this. Select this group, click the left view till here. Just select the members, selected objects. Now click on isometric view, select beam parallels to Y, inverse the selection, again view, selected object. You can also save this view by clicking on this view management, save view and write the name as suppose external walls. Click on OK. So whenever you want to see this view, you can simply click on view management and see the view. I'll click on this top view. I'll just select the external walls. To be sure, I'll click on isometric view and check. Yeah, I want to assign this under one group. Assign to selected geometry, associate. So first I'll click on this display hall structure. So if you want to check like what are the members under this group, click on this highlight option. So this is a group. This is the these are the members that are under the B1 group. Click on this 13.2 kilonewton per meter square. Click on this group. Like if you want to open the group, click Ctrl plus G. Select this group, highlight. Now assign to selected beams. See, this is how easily you can assign the member load. Like I think instead of selecting each member again and again, just create a group, click on the load, click on the group, highlight the geometry, assign to the selected geometry. It's assigned to the selected beams. Now to assign this load, just select this beams, selected objects, top view, because we don't want to assign this load on all the members. Like on the members that you want to assign the load, just select those geometry, create a group, name it as B2. Sorry, B2. Select type as beam. Okay. Select this, assign to associated geometry. Click on this load, this group, highlight, assign to selected beams. Assign. See, this load has been assigned. Now we will assign this last parapet wall load. In the similar way, I'll just select these nodes, these beams, selected objects. This is a very small structure that I'm working on. You might be like working on big projects. So these group option will be very, very useful in those projects. Might be you be thinking it's not beneficial, but yeah, it will be in the in the big projects. I'll create a group, name it as parapet, select type as beam. Okay. Associate. I'll just click on this. I'll click on this group, highlight, associate to selected beams. So this is how you can assign your member loads by using grouping method. So I have shown you like one by one, like manual method by selecting the objects and then assigning the loading. And second is to create a group. Also, you can see the group like you can go in select option. Here you will find the group option, like how many groups are available in your structure. And suppose if you'll change the loading, it will be changed in all the 3 floors. So just be very careful while creating the group or changing the loads, because suppose there is a change in beam sizes or anything. So load will be changed automatically. Suppose it is now 13.5. So on all the floors, loads will be changed 13.5. So on all the 3 loads, now the loads has been assigned as 13.5. So just you have to be very careful while assigning the loads in groups, because if you there is a change in a single floor, it will be changed in all the floors if all the floors are assigned in the one group. So now moving on to our floor load part. I'll click on floor load. So this is why I have created another load case, because while moving to floor load, all the member loads have been hidden, because I have created the member load case separately. So while using the member loads only, then I'll be able to see my floor loads. Oh, sorry, member loads. Now I'll be creating floor loads. So in the similar way, I'll just click on this floor load, click on add, click on floor loads, and write down loading. So first we'll be assigning the load in first floor, selected objects, and isometric view. So yeah, suppose I have like assumed 2 types of load. One is like for the internal wall, the slabs which are consist of internal walls, and the slab which are not consist of the internal wall. So there are 2 types of load cases available. One is 5.2 and second is 7.2. So I'll be assuming the slabs like suppose first let's create 5.2 load case. I'll write here 5.2 in ranges. Now comes the ranges method. So basically range method is used to locate a strip of area. One needs to like specify a maximum range value and a minimum range value. The program searches for a floor within the specified range. Like suppose my y range is 3 to 6, and I have specified the x ranges and z ranges and both their minimum and maximum ranges. So program will search for the floor within that specified ranges, and if you don't specify any range, then the program selects all the available floors to apply that particular floor load. So um, suppose my this whole panel, in this like whole area, there is no internal internal wall available. So I'll just click on this node cursor. I'll first click on this node, my first initial node. Here my y range is 3, so I'll write the minimum range as 3 and maximum as 4. Let's say 3 to 4. And till here, or I'll say, yeah, till here there is no internal wall in these slabs. So here my maximum X value, if you have noticed, well, when I clicked on this node, 0 and 0 was a Z and X minimum range. And when I clicked on this node, X value has been changed to 10, maximum value, and Z is 16. I'll click on add, close. See, this is how I can add my floor load and assign using the ranges method. And suppose in this area, I want to apply the internal wall load, that was 7.2. Again, I'll click on floor load. Here I'll write minus 7.2. So just remember, while applying the load on the same floor, wire ranges will remain same, 3 to 4. Now click on this node now, because I'm applying the load in this area now. So this will be my initial node for this area. So here minimum X range is 10 and minimum Z range is 8. Now click on this node. Here maximum is 16 and here maximum is 20. Sorry, it's 20. Click on add, close. Wait, I think I have done some. Let's create one more time. Minus 7.2. Here range will be 3 to 4. Here X is 10. Z is 8. Here Z is 16. And here it is 20. I'll click on add, close. See, my load has been assigned. So you might be thinking, why haven't assigned this same load in these panels also? Because if I'll do it, it will show an error. Suppose I'll click on this. Here Z maximum is coming as 8, but here it is 16 in this node and X is 20. Maximum range is 20. Suppose I'll say, let's say 20, modify. But this load has been assigned in this panel also. As you can see, this blue lines like overlapping, the loads are overlapping. That's why I didn't apply the load on those panels. Now for these panels, I'll again have to create this load case. Suppose I'll say again floor loads minus 5.2, ranges 3 to 4. I'll click on this node. My minimum is 10. Z is 0 as minimum. And Z is 8. X maximum value is 8 and X maximum value is 20. Click on add and close. See, my now load has been assigned. See, in here now, no blue lines have been created, like no overlapping load is there. So this and this. So like while assigning the loads and like while creating the floor loads and for the live loads, you again have to define these ranges. Like suppose click on live load, click on add, click on floor load. Just for an example, I'm taking that like this half of the floor is having the value of minus 2 kilonewton per meter. Y range is 3 to 4. X is 0, Z is 0, X is 20, and Z is 8, and maximum value. I'll close this. The load has been created. Now I'm creating the second load case. Suppose it's 3. Sorry, I guess I have created some mistake in that, but it's okay. 3 to 4. Click on this node. Here X is minimum is 0 and Z is 8. And here Z is 16 as maximum value and X range is 20. Click on add, close. In this 3 to 4. Modify it, close. See, first half is -2, second half is -3. So you have to again like create the Y ranges and that load, live load. Suppose there is one more load cases there, then you again have to define the Y ranges. So, and this is for the first floor. Suppose this is the master floor or the master story, and all above stories are similar to this floor. So what I'll do is I'll simply click on this node and I'll see the Y range. It's 9. So instead of 3 to 4, I'll write here maximum as 9. I'll click on modify, close. And like all the load cases that I have created, I'll do the same thing. I'll simply change this Y ranges. This is how you can do or assign your loads using the ranges method and assign the same similar load on the above floors. You just have to change the Y ranges in this because we are going upwards. So see, all the loads have been assigned using this Y range method. Now moving on to the second method, which is grouping method. Okay. So what I'll do is as of now, I'll hide these loads that we have created. To do that, how you can access command file, go to utilities, or which is that editor file. In Connect Edition, it has been replaced the name as command file, and you can find it under utilities tab. Click on this command file option. Just save this. I'll go to my loading part and I'll just simply comment this. Comment means now all these floor loads will be hidden. I'll just be able to see the load cases that we have created. See, I haven't hidden this member loads. I've just hidden the ranges method loads. So in floor loads, let's create the group now again. What I'll do is first I'll select the view. I'll just select this load. Sorry, this first floor beam. Click on selected objects, isometric view, Control plus G. Similar way, just click on create. Write the floor name as F1 and here select type. Now here you have to select the type as floor because you are assigning the floor loads. Click on OK and select the floors, and select the panels in which you want to assign the similar kinds of load or the panels which are having the similar load. What I'll do is first I will just select the members, like horizontal members. View selected objects. Now, yeah. Suppose these panels have the similar loads. These panels also have the similar load. Like if you remember while creating in the ranges method, I have created the separate I have defined the separate load for these panels and for these panels. But in group, we can assign these groups in these panels under a single group. Click on associate. Again, create a group and say write the name as F1 walls, so that you know ki this is the group name for the panels consist of internal walls. Click on OK. Like create the group name whichever is like you can remember. Associate. Now what you can do is click on floor load, click on add floor loads. Now instead of Y range, like there is no pressure of again clicking, double clicking the nodes and seeing the ranges of them. You simply click on group. You just have to remember the groupings, like which group has how many panels or what is the group. So click on F1, or if even if you forget, just click on this, highlight and see. So F1, click and write the pressure as say 5.2. Click add. My group has been added. Click on F1 walls now. Say 7. Click on add. Close. See how easy it is. Like, I mean, I feel this grouping method is easier way to assign the loads because it makes your work easy and workflow easy as well. And whosoever is checking the structure will also will be easily check this. So in while creating live loads, you don't have to create separate loads. Oh, sorry, yeah, separate loads. Like in the ranges method, you just have to go on floor loads. Group will be same, just write your values. But just make sure that all the groups that you have created, that you have highlighted in the same group are consider of the same load type, or same load need to be assigned on that. So this is how you can assign the grouping, loads in grouping. But yes, there is a single change in this. Like in Y ranges, you just need to change the Y ranges like 3 to 4. If you want to assign the loads in overflow, then just select the Y ranges. But in this grouping method, you have to be very careful while assigning the loads in group, because if you assign the same group in the above floor as well, and without selecting or without highlighting the geometries before that were under the similar group, it might you might delete the loads like you have previously assigned in that group. Like if I may show you, suppose I'll select the above floor, and this was F1, right? And we have selected all of these panels under, under this one group. Just see what I'm doing. I'll click on associate now, but I'll click on display whole structure and see loads from my lower floor has been now deleted. So if you want to use a similar floor group on the above floors, what you need to do is first you have to select this, then highlight this so that all the geometry is highlighted under this group that was previously assigned in this group. Now go to this tab, or just first select the floor in which you want to assign the group. Uh, okay, now wait. I'll just select the horizontal beams. That's fine. Okay. So now what I was saying is first highlight this geometry. Don't worry, it's already been highlighted. Just press Control now. And now select the objects. Now associate. See, now the loads have been changed from that upper floor to the lower floor. So like I told you, you have to create the separate groups for the separate flows, and it's a best way to approach the loadings while assigning the loadings to your model, and it will not like delete or any kind of load them. So just create the separate groups for the separate flows while working in the groups. And if you are working in the ranges method, I've already told you like how you can see the maximum and minimum ranges in your model. So this was like all for like today's session, because I'll be I'll be guiding with wind loads and wind definitions. If you want me to cover wind definition, then please do write to me on my mail ID, or you can contact me as well. Um, yeah. So this is my mail ID and my number on which you can just reach out to me. So I think this is a question answer session now. So if you have any kind of questions regarding anything the session, so please do ask me, or you can write in the chat box. I request you all to please write your questions if you have any in the question and answer chat box. I'll answer them. Anyone, any kind of question regarding anything, please do write on chat box. I'm waiting for your questions.